No matter how long we stare into the dark, there is a moment where the universe stops giving us older light. Not because our mirrors are too small, not because we forget how to build better telescopes, but because the cosmos has rules, and one of those rules is painfully simple. Information cannot arrive from everywhere. And if that is true, then the edge of the universe is not a wall you can touch. It is a boundary made of time, speed, and the strange way space itself grows. If you want more gentle, space-themed journeys like this, you can subscribe, and we'll drift together again on another quiet night. Now let's lower the volume of the world and follow the last light we are allowed to receive. Imagine you are floating far beyond Earth, where the planet looks like a calm lantern with a thin blue halo. You do not hear traffic. You do not hear weather. You only hear your own breathing, slow and steady, and the soft internal clicks of your suit. In front of you, the universe is not a picture. It is a depth. You pick a direction, any direction, and you look. The closest things are familiar, stars in our own neighborhood, bright and sharp. Then come the faint smudges of galaxies, so far away they barely feel real. The farther you look, the younger everything becomes. Galaxies look smaller, more chaotic, more crowded with newborn stars. Keep going, and you reach an era where there are no galaxies at all, only a glow, a thin, ancient haze spread across the sky like the memory of a fire. And then, after that glow, the universe goes quiet in a new way. Not quiet as in empty, but quiet as in unreachable. A gentle companion joins us, like a soft voice that never interrupts your calm. When you say, "We can't look any further," do you mean we hit the end of space? No. And that is the first secret to hold tonight. We do not hit the end of space. We hit the end of what can talk to us. So our central question is this: what really stops us at the edge? What is the deepest reason the universe can only show us so much, even if we build perfect instruments, even if we wait, even if we become unbelievably patient? And we'll plant a few small promises early, like stones along a path, and return to them at the end. First, we keep returning to a single ancient photon, because every cosmic story that reaches you arrives as a tiny packet of light. Second, we keep returning to a horizon, not as a place, but as a rule, because a horizon is not an object. It is a boundary made of perspective. Third, we repeat a phrase that stays simple enough to carry into sleep. The edge is made of information. Now, to understand why we can't look any further, we first need to untangle a confusion that lives in almost everyone's mind. When people hear "edge of the universe," they picture a border. They imagine a ship sailing until it bumps into the end of the map. But the universe, as far as we can tell, does not behave like that. Space does not seem to have a rim we can reach. The edge we talk about is not the edge of space. It is the edge of our view. It is the boundary of the observable universe, the portion of reality that has had time to send light or any signal to us, since the universe becomes old enough to allow that signal to travel. That last part matters more than it sounds, because the universe is not only big, it is also young, at least compared to the distances involved. It has an age, and light needs time. So here is the first stopping force, the calmest one, the one that does not care about our feelings. The universe has a speed limit. Light moves incredibly fast, but not infinitely fast. And the universe has only existed for so long, so there is only so far any light can travel before it reaches us. That alone creates a boundary, a cosmic distance beyond which the light simply has not arrived yet. If you feel a small chill in that idea, you are not alone, because it means that right now, at this moment, there are places that exist, but their stories cannot reach you. Not yet. Maybe not ever. So even if we wait, the light from farther places eventually arrives, right? Sometimes it does, but not always. And this is where the edge becomes more than a simple not yet. Because the universe is not sitting still while the light travels. Space itself expands. The distances between faraway regions can change while the photons are in flight. That expansion complicates the boundary. It means the farthest light we see now does not come from a distance equal to age times speed. It comes from a distance shaped by how the universe expands while the light is traveling. To make this feel gentle, imagine a long moving walkway at an airport. You stand on one end, and far away, someone rolls a ball toward you. The ball moves, but the floor beneath it moves too. By the time it reaches you, the whole corridor has shifted. In the universe, light travels toward us, and space expands while it travels. The result is not a simple map, but the important feeling remains. There is a boundary made of travel time. Now, we slow down and ask something even more basic. Even if light has time, can it always travel? Because there is a second stopping force, older than galaxies, older than stars. It is not about distance at all. It is about transparency. In the very early universe, light does not move freely. The universe is hot, dense, and filled with charged particles. Photons scatter over and over again, like someone trying to cross a room so crowded that every step ends in a collision. In that era, the universe is not dark. It is bright, but it is also opaque. Then, as the cosmos expands and cools, atoms form. Electrons settle into place. Suddenly, photons stop bouncing around so much. The universe becomes transparent enough for light to stream out in straight lines. The light released at that moment is still here. It has been, traveling ever since. It has stretched as space expands, cooling into microwaves. Today, we see it as the cosmic microwave background, a faint glow in every direction. And that glow is our oldest photograph, our earliest screen. If you ask, why can't we look further? One answer is this: because before that moment, the universe is not see-through. You can build a stronger camera, but you cannot see through fog by making your eyes sharper. You need a different kind of messenger. And now, we feel the edge forming, not like a wall, but like a mist line on a lake at dawn. Beyond it, the lake continues, but your sight does not. The edge is made of information. So, the cosmic microwave background is the edge. It is an edge, but not the only one. And this is where the story becomes quietly layered. There are multiple edges people accidentally compress into one idea. If we separate them, the universe becomes less confusing and more haunting. There is an edge of time, the farthest light that has had time to reach us. There is an edge of opacity, the farthest back we can see using ordinary light. And there is an edge of forever, a boundary beyond which signals may never reach us, even if we wait until the stars burn out. That last one sounds dramatic, but it comes from a simple fact that modern cosmology takes seriously. The universe's expansion appears to be accelerating. And in an accelerating universe, there can be regions so far away, receding in such a way, that light sent from there now will never arrive here. Not because light is weak, but because the space between us and that region grows too quickly for the light to ever make net progress toward us. This is called a cosmic event horizon, and it is a different kind of edge than the edge of not yet. It is the edge of never. If that feels heavy, let's keep it gentle. We are not trying to frighten you. We are just tracing the shape of reality. So, to understand why, we can't look any further. We need to travel through 3 boundaries, like 3 doors in a long hallway. The first door is the limit of time and speed. The second door is the limit of transparency. The third door is the limit set by accelerating expansion. And beyond each door, the universe continues, but our connection to it changes. Now we begin our long journey, and we keep it calm, steady, and continuous, like a slow orbit. Let's start with the first door, the easiest to imagine, and the one your intuition almost gets right. Light takes time to travel. That means when we look at something 1 light year away, we see it as it was 1 year ago. When we look at something 1,000 light years away, we see it as it was 1,000 years ago. That is already strange, but it still feels manageable. Then you look at a galaxy millions of light years away. The light begins traveling before humans have cities. Then you look at galaxies billions of light years away. The light begins traveling before Earth has complex life. And you begin to realize that the universe is not an image. It is a layered archive. Every direction contains history. So the farthest we can see is the farthest history we can access. But here's the quiet twist. The universe expands. While a photon is traveling, the space it moves through stretches. This stretching does 2 things. It increases the distance between us and the place the photon came from, so that place is farther away now than it was when the photon started. And it stretches the photon's wavelength, shifting it toward redder light, eventually into infrared or microwaves. So looking far away is not only hard because objects are faint, it is hard because their light changes on the way to us. That is why modern telescopes that can see infrared become such powerful time machines. They catch light that has been stretched by expansion. But even with perfect infrared vision, the first door still stands. Light has had only so much time. There is only so far it can come from. So you might think, fine, that means if we wait longer, we see farther. The boundary grows. The universe slowly reveals more. Sometimes that is true. But then the third door appears, the one we will return to later, because not all light that could exist will ever arrive. For now, though, we stay with the first door and make it feel intimate. Imagine an ancient photon leaving a newborn galaxy. It does not aim for us. It simply leaves. It passes through the galaxy's dust and gas. It escapes into intergalactic space. It travels for billions of years through expanding space-time, through the quiet emptiness between galaxies. It survives. It stretches. It thins. And then, finally, it arrives at our instruments. A single photon, a single piece of information. Everything we know about the far universe begins with that. And beyond the farthest photon we have received so far, there are photons still traveling. Their stories exist, but they are still in flight. So the edge is made of information. Now we move to the second door, the one that feels like a real barrier, the one that makes people say, "We can't look any further," with finality. The universe is not always transparent. There is a time early on when photons cannot travel freely. They keep scattering. They are trapped in a bright fog. Then the universe cools enough for neutral atoms to form. Photons finally stream freely. The moment those photons last scatter is what creates the cosmic microwave background, a kind of shell around us, not in space you can touch, but in time. It is the oldest light that can reach us directly. When we look at that background, we are looking at the universe as it is when it first becomes see-through. And we cannot see earlier with light, because earlier, light cannot carry clean images across the cosmos. This is why, even if you build a telescope the size of a planet, you still will not see before that surface using photons. Not because you are weak, but because there is no straight-line photon information to collect. If that feels like the universe slamming a door, it helps to reframe it. It is not a door. It is a phase change, like water freezing, like steam condensing. The physics changes, the medium changes, and information routes change with it. Archivist. If light cannot show us earlier, what could? Other messengers. Neutrinos, for example, interact very weakly with matter. They can pass through dense material that would trap photons. In principle, there is an ancient neutrino background, released far earlier than the cosmic microwave background. If we could detect it cleanly, it would be like hearing a deeper layer of the universe's earliest story. Gravitational waves, ripples in space-time itself, can also pass through the early universe in ways that light cannot. In principle, waves generated in extremely early moments could still exist as a faint background, a subtle cosmic hum. So the second door is only a photon door. It is not necessarily the end of all possible observation. But, in practice, those other messengers are hard to detect, especially from the earliest times. Their signals are faint. The background noise is tricky. Our detectors are still learning how to listen. So for now, for our actual human instruments, the cosmic microwave background remains a practical edge of seeing. Now we can feel the story tightening into something real. The universe limits us in multiple ways. Even if we solve one problem, another remains. We can build bigger mirrors, but time is still finite. We can collect older light, but early opacity blocks photons. We can imagine deeper messengers, but detection is still young. The edge is made of information. Now we drift into a more personal layer. Because when people ask about the edge, they often carry a quiet hope behind the question. The hope that if we just keep going, we will finally arrive at a final truth, a final boundary we can reach, a place where the universe ends and certainty begins. But what if the opposite is true? What if the farther you go, the more the universe becomes about limits, horizons, and what cannot be known from a single location? Let's explore horizons gently, because horizons are one of the strangest ideas in all of physics. A horizon is not a wall. It is not made of material. It is a boundary defined by what can reach you. On Earth, you have a horizon too. If you stand by the ocean, the horizon is where the surface curves away. You cannot see beyond it, not because the water stops, but because the geometry of your position and the curvature of Earth limit your view. Cosmic horizons are like that, but instead of Earth's curvature, it is space-time itself. And instead of your eyes, it is information traveling at light speed through an expanding universe. So when we say, edge of the universe, we are really saying, our horizon. And here's a subtle question that often comes next, even if people do not say it aloud. If we have a horizon, does that make us the center? No, not in any special cosmic way. It only makes us the center of our own observable bubble, the way you are always the center of your personal horizon on Earth. Every observer, anywhere, has their own horizon, their own observable universe, their own edge. So the edge is not a location in the universe. It is a relationship between you and the rest of reality. That is both humbling and oddly comforting. Now we move deeper, and we do it slowly, because this is where the third door begins to come into focus. Even if time passes, even if we wait, even if the universe grows older, do we always see more? Does the horizon always expand? The answer depends on how the universe expands. In a universe that expands but slows down, the observable region can grow in a way that eventually reveals more and more. But if expansion accelerates, there can be a limit to what we will ever receive. This is the cosmic event horizon idea again. It is a boundary beyond which events cannot ever affect us, even in infinite time, because the expansion of space keeps separating us too quickly. To keep it gentle, imagine you are swimming in a river with a current that gets stronger the farther out you go. You can swim at a certain maximum speed. If the current is weaker than your speed, you can make progress. But if the current becomes stronger than you can ever swim, there are regions you cannot reach, no matter how long you try. Light is like the fastest swimmer. Nothing outruns it. But even light can fail to reach us if the current of expansion, in a certain sense, carries distant regions away too quickly. So the third door is not a door of material. It is a door of dynamics. If expansion continues accelerating, some regions become permanently disconnected. That means there are parts of the universe that may already be beyond our forever horizon. Not because they are behind a wall, but because the geometry of expansion keeps their signals from ever arriving. If that makes you feel a quiet ache, that is normal. It is the feeling of limits. But we are not done, because there is another layer to this. The edge is not only about what cannot reach us, it is also about what we can reach with different kinds of observation. So let's take a calm inventory, not as a list, but as a drifting tour. We have telescopes that see visible light. They show us stars and galaxies, mostly in the relatively recent universe. We have infrared telescopes that see stretched ancient light, revealing earlier galaxies. We have radio telescopes that map cold gas and cosmic background radiation. We have instruments that detect high-energy particles. We have gravitational wave observatories that listen to space-time tremors. Each is a different sense. Each can reveal a different part of reality. So when we say, we can't look any further, we should ask, further with which sense? Because the photon sense hits an early fog wall, but other senses might, one day, peek deeper. Does that mean the edge can move? The photon edge is fixed by physics, but the human practical edge can move as our instruments improve. That is the difference between a fundamental horizon and a technological horizon. We can always improve the clarity of what we see within the observable region. We can see fainter galaxies, weaker signals, subtler patterns. We can also learn to interpret what we already see more accurately. And that, in a way, is like seeing farther. But some boundaries remain. No telescope can collect light that never arrives. No camera can see through an opaque era using photons. No instrument can receive a signal from beyond a forever horizon if the universe's expansion prevents it. So we are stopped by physics itself. Now we begin to stitch all this into a continuous story, not separate concepts. You are here, now, on Earth, looking outward. The universe has an age. Light has a speed. Space expands. Early on, light is trapped. Later, light escapes. We catch it. Farther out, expansion stretches it. Farther still, expansion can pull regions away so that their light never reaches. It is all one narrative, one chain, and the chain ends, for us, at an edge made of information. Now we take a quiet detour into the cosmic microwave background again, because it is the most famous edge, and it holds a hidden lesson about our expectations. When people first learn about it, they often imagine it like a wall at the end of the universe. But it is not a wall. It is a time surface. It is the earliest time from which photons can stream freely to us. If we could stand at a different location in the universe, the cosmic microwave background would still exist for that observer, and it would still appear as a shell around them. It is not a literal boundary in space. It is a boundary in time, seen as a boundary in the sky. So the edge is not out there. It is back then. That is why cosmology feels like a study of the past more than a study of distant places. Distant places are distant pasts. Now let's add another quiet complication. Even within the cosmic microwave background, we do not see perfect smoothness. There are tiny variations, small temperature differences across the sky. Those variations are like the seeds of structure, the early ripples that later grow into galaxies and clusters. So even at the edge of photon visibility, there is information. Not images of objects, but patterns. Not cities, but the faint imprint of the landscape before cities exist. That is another kind of seeing. Seeing through statistics and structure rather than through pictures. And it hints at something important. Even when we cannot see earlier directly, we may infer earlier conditions through imprints left on what we can see. But inference is not the same as direct vision. It is more like reading footprints than meeting the animal. So the edge is made of information, and information can arrive in different forms. Now, we move into the part of the story that feels almost philosophical, but it is still physics. The universe might be much larger than the observable part. It could be infinite. It could wrap around. It could be finite but unbounded, like the surface of a sphere but in higher dimensions. We do not know the full shape with certainty. We only know what we can measure. And what we can measure is limited by our horizon. So when people ask, what is beyond the edge? The honest answer is more universe, most likely. but we cannot see it directly from here. This frustrates the mind because it wants a picture. But perhaps it is enough to know that our bubble is not everything. Now we return to the third door again, because it has a quiet cruelty in it that we should address with care. If expansion accelerates, the far universe can slip away over time. Over unimaginably long timescales, galaxies outside our local gravitational neighborhood can fade from view. Their light becomes more redshifted. Fewer photons arrive. The sky can become darker, not because galaxies vanish, but because their messages no longer reach. So the edge is not only a boundary of past visibility, it is also a boundary of future connection. That means the observable universe, in some sense, can shrink in terms of what remains practically visible in the far future. This is not something you need to fear. It is too slow to affect human lives. But it is a reminder that the universe's story includes phases, and in some phases, horizons tighten. And now, we let the archivist ask a question that many people carry quietly. If there is an event horizon, does that mean some places are already unreachable, even though their light from the past reaches us now? Yes, that is one of the strangest parts. We can receive light today from a galaxy whose current state might never be able to affect us. We can see its past, but not its far future. We can watch a history that continues beyond our ability to ever interact. That means seeing and reaching are not the same. We can see farther back than we can influence. We can look at the past of regions that may be forever beyond our future causal contact. If you sit with that for a moment, it feels like watching a distant ship through a telescope, while knowing you can never sail to it. The edge is made of information. Now, to keep the momentum, let's build a gentle micro-arc. We ask a simple question. If the cosmic microwave background is the photon edge, does that mean there is a deeper edge, a deeper background, a deeper screen? In theory, yes. There could be an ancient neutrino background, decoupling earlier, carrying information from an earlier time. There could be a gravitational wave background, perhaps seeded by very early processes, possibly even inflation, if inflation happens as many models suggest. Those waves could carry information from extremely early moments when the universe is unimaginably hot and dense. If we could detect that, it would be like hearing a story that light cannot tell. But here's the catch. The earlier the messenger, the harder the message is to separate from noise, because everything in the early universe is intense, and the signals get diluted over cosmic history. So for now, the cosmic microwave background remains the deepest, clear photon layer. And that is why, in practice, we often say we cannot look any further. But even within that limit, there is wonder. Because the boundary is not blank, it is textured. It contains the imprint of early conditions. It contains the seeds of everything later. It is an ending that is also a beginning. Now we shift again, because the title says, what really stops us? And we have been talking about the universe's limits. But we have not yet addressed the human instinct that insists, surely, there must be a way around. Maybe we could travel to the edge. This is where we need to be careful, because the edge is not a place. It is a relationship. If you travel far away, you do not travel to the edge of the universe. You carry your own horizon with you. Wherever you go, the observable universe is centered on you. Not because you are special, but because observation is always local. So you cannot sail to the edge like a cliff. You can only change which region of the universe is within your horizon, and that change is constrained by the same rules. Even if you travel at incredible speeds, you still cannot beat light, and you still cannot access regions whose signals cannot reach you due to expansion. So travel does not escape the horizon, it merely shifts the bubble. That can feel disappointing, but it is also elegant. The universe is consistent. Now we return to our ancient photon again, because it is the smallest symbol of the biggest limit. The photon is not a magic thing. It is simple. It carries energy and information. It moves at the speed limit. It is stretched by expansion. It can be scattered by plasma. It can be absorbed by dust. If the photon cannot reach you, you cannot see its source, no matter how powerful your telescope is. So one stopping force is simply no arrivals, no knowledge. The edge is made of information. Now we move into a softer, more reflective section, because this topic can become technical, and we want it to remain a sleepy story. Think of your life as an island of perception. You can only know what reaches your senses. Sounds that never arrive do not exist for you. Light blocked by walls does not exist for your eyes. Smells carried away by wind never reach your nose. You can infer, yes. You can imagine. But direct knowledge is limited by delivery. The universe is the same, but grander. It delivers signals. We build receivers. We infer what we can. But delivery still limits knowledge. So the edge is not a punishment. It is the geometry of being inside space-time. Now, let's give your mind a simple picture that ties the three doors together. Picture 3 layers of distance in front of you. The nearest layer is the universe where light travels freely and has had time to reach us. We see stars and galaxies, and we can keep improving our clarity. The next layer is the universe where light travels freely but has not had enough time to reach us yet. The stories exist, but the photons are still in flight. The third layer is the universe where, because of the way expansion behaves, some stories may never reach us, no matter how long we wait. Then, separate from these, like a different axis, is the early time when light cannot travel freely at all, when the universe is opaque. That sets a hard limit on photon vision backward in time. So we are boxed in by time, expansion, and transparency. That is what stops us. Now, we bring in one more quiet twist, because it helps explain why these limits feel emotionally intense. We humans are used to boundaries that are negotiable. Mountains can be climbed. Oceans can be crossed. Even the sky can be flown through. When we find a limit, we assume it is temporary. But cosmic limits can be absolute. You cannot engineer a way to receive light that never arrives. You cannot build a camera that sees through an era where photons cannot travel cleanly. You cannot choose to wait long enough if the geometry prevents signals from ever reaching you. So the universe teaches a new kind of humility, one that is not about giving up, but about understanding the shape of what is possible. Now, we glide into the final part of the journey, where we pay off what we promised. And we do it in a way that feels like the story continues all the way to the last line. We promised the photon. Here it is again, and now it carries the whole meaning. A photon leaves the early universe at the moment it becomes transparent. It travels for almost the entire age of the cosmos. It stretches until it becomes microwave light. It arrives as a faint whisper in our detectors. That whisper becomes a map of tiny variations across the sky. Those variations become a clue to how galaxies eventually form. From a single ancient photon, we learn the outline of everything. Then we promised the horizon. Now we can see it clearly. The horizon is not a wall. It is the boundary of connection, defined by what can reach us. It grows with time, but it is also shaped by expansion. And in an accelerating universe, it can set a forever limit. Then we promised our phrase, and now it returns with full weight, soft and steady. The edge is made of information. So what really stops us at the edge of the universe? Time stops us, because the universe has only been delivering messages for so long. Opacity stops us, because the early universe does not let light carry pictures. Expansion stops us, because the geometry of a growing cosmos creates horizons that no technology can remove. And still, within those limits, we see astonishing things. We see galaxies forming. We see the glow of the early cosmos. We hear ripples in space-time from colliding black holes. We push deeper each year, not by breaking the rules, but by learning how to listen more carefully. If you'd like more calm, space-themed stories like this, you can like and subscribe, and we'll keep drifting along the horizons together. And somewhere, far beyond the last galaxy we can ever reach, a photon begins a journey toward us. But the universe expands, the distance stretches, and the message never arrives.